bit about complex numbers. Did anybody figure out what happens when you multiply by I? Did anyone figure that out? Do you want to try it?
You get xi if you multiply x by I.
But what if you multiply any complex number or a shape? All the points in a shape by I. What happens to the shape? That's my question. What does it do? What does multiplying points by I do?
Dimension.
No, it stays on the complex plane. I don't think anyone tried that. All right. So there is something really interesting to discover there. I'm just going to mention. So we were talking about complex numbers. We could do a little bit more of that. Another thing we could talk about is braid groups.
Ooh, let's do braids and complex numbers.
We could talk about braid groups. We could talk about symmetry groups, like what happens when you take a square and you flip it around different ways.
So translate?
We could talk about banana split axioms and go with that. Develop our own crazy math. Yes,
What about origami axioms?
we could do origami
I know how to
axioms.
do
So let's talk about what are we going to do today? What do people want? What would you
Can we
like?
vote more than once?
Well, I'm going to let you see which things you are interested in today.
I don't know.
Okay. Do you have an opinion, Josh?
Huh?
Do you have any opinions about what you'd like to see us do today?
No.
Luca?
Braids.
Yeah.
All of the above.
Okay.
Braids.
Okay. Braids.
Okay, looks like it's braids.
Origami.
Braids and origami. Okay.
Oh, I
Actually, I do.
And some people have got votes for the banana split.
I know.
What?
Mm.
I thought you knew.
I said
Poker
it, but I
face?
forgot.
Oh, well, all right then. So,
Actually,
let's talk about
No,
braids.
I know it again.
Yes.
Is it like? Oh, I forgot.
So, braids are interesting because braids are a good example of a group. Now, we talked about fields before. And fields had all kinds of crazy axioms. There was the associative property, the commutative property, what else? Do you remember?
Ooh,
Distributive property of multiplication over
identity property.
addition. The identity property, we had inverses, we had all this stuff. We had two operations. We had addition and multiplication, right? So now, we're going to just talk about something that's simpler. It's called a group. And to be a group, you need a couple things. You need a set of objects. They might be numbers, they might be braids. You need an operation to combine the objects.
We could just
Now-
we can have a group of making.
What symbol do you want me to use for the operation? It can be anything crazy you want. Yes.
Let me see.
Can it be
Different. Okay, I make up.
Can it be a double helix?
Can I draw that? How would I need something I can draw pretty easily. Yeah, do you have an idea for what I should do?
A unicorn horn. It just looks like that.
Like this?
The
Yeah.
spiral.
No.
With a spiral around it?
How about this?
Oh no, that's a narwhal horn. Think
What's
about
that?
it. Narwhal.
A zero with an X through it?
Yeah.
That would be pretty good too.
That's just something right.
Well, okay. So here that would be a good. I'll save that
Wait,
one.
I have another
We'll use that next time. So we've got a unicorn horn with a spiral on it. That's going to be our operation, and our objects. Well, maybe I should use. This is going to be one of the objects. Actually, I'm going to call them this one with a 1 by it, this one with a 2 by it, and just put some different things like that. It's really math. Why are we calculating unicorn horns?
I don't like unicorn horns.
Of these? I don't know. But here's what they have to do. Here are the properties. We have to have the identity property. What's the identity property? Well, actually, we have to have an identity element. Back up. What's an identity element? You need an identity element? Yeah?
Something that you use.
It's like 0.
It's like 0 in which operation?
In addition and 1 in
Multiplication,
multiplication.
right? It's a do-nothing element. So what might your do-nothing element be? Maybe, well, it might be 0. Or it could be
pi.
1.
Let's make
Or it could be any other crazy symbol. But it's a
make it
do-nothing
tau.
element.
Let's
When
make
the
it tau.
unicorn- So in particular, if you unicorn horn anything with 0, you get the anything, right?
Unicorn horning looks suspiciously like addition.
It does in this case, doesn't it?
Yeah.
Okay, so that's the identity.
Maybe there's a giant.
There's the identity element. Now we also need inverses. Every element has to have an inverse. So if you have this element and you unicorn horn it with some other element, I'm just going to call it, -1. Why not?
Wait, how is this braids?
That would be 0. Oh, we haven't got to the braids yet. We're just getting to the what is a group. So we've got identity, we've got inverses, and then we have 2 more things that we need. One is associativity. What does that one mean again? Also known to its friends as the what property?
Associative.
Yeah, and it's the associative property. What can you do? Yes?
If you have parentheses, you can move the parentheses around.
Right, this is the hey, you can move parentheses around property.
What if we
Mrs.
don't
Jacobs
want an
or
associative
Mrs.
clause?
Hessel said they were
Associating
using the numbers to
Yours.
associate with someone else.
Yeah, you're letting the numbers associate with somebody else by moving their parentheses. Okay, and the last one is,
Bananas.
closure.
Closure?
Closure, actually that's more like the first one. The rule is, suppose you took 2 of these crazy elements and you unicorn horned them together. You should not fall out of your set. You should get something else that's still in here. So closure means you can't fall out of your set by unicorn horning things together. Has to stay. Your set has to be complete. Closed. Yeah, those are the 4 things that you have to have for a group.
About,
So now let's do braids.
but
No,
what
I'm
if,
still writing that down.
but what if one number
Wait, what is
one
what is
line
inverse
or
called?
had an exact copy in another set? In that number line. Or a group.
You need what if you had a different
An
group?
exact copy in another.
That's allowed. You could have a completely different, like you could have the same numbers in 2 different groups and they're doing different things.
I have
That's
an
okay.
idea for something that might
Yeah.
be
What if they
interesting.
do the same, like absolutely the same?
Then they might be the same group.
Can we make it so the symbol for positive is that, but the symbol for negative is that rotated? So it's like a plus sign instead of an X?
Oh, that's a good idea.
Yeah.
Well, maybe when we get to our banana split axioms, that's what we'll do, when you guys invent your own. Well, let's do the braid ones really quick. So braid group. Okay. Let's be specific. How many strands do you want in your braids? 3 or 4?
3.
53.
I don't want to draw 15.
3.
No, 3.
1.
Okay, 2.
3, 4.
Negative 3.
Let's go with 4, just because it gives us room. So we're gonna have, but we could do it with any number. 4-strand braid group. So here's what we're gonna do. Here's how it works. You take thumbtacks. Okay?
Thumbtacks?
Sure. And you have strings that are dangling out, they're fixed, they're pushing in.
Do we draw this?
Sure. And what happens with the braid is that they cross over each other. Now, the way I like to draw these is each crossing is just an X between 2 that are near each other, where one goes over and the other one goes under. You can have it be either way. So those crossed right there. I could have maybe these cross over here. I'm going to let these cross now. Why not? You can draw your own braid on your paper.
My braid is prettiest.
But usually there's only 2 of them, maybe there's a couple crossing at the same time, but you don't have 3 crossing at the same place at the same time. It's only 2 at a time. Otherwise it's too confusing. So we do that. maybe we'll have this one go under over here, okay? And maybe we'll have this one
Looks like
go under like that.
Oh no, it's
And then we take our thumbtacks and we nail them down at the end.
Ooh.
That is a braid. A braid is it's a set of 4 strings that got nailed down at the top. They crossed some kind of way in the middle, and then at the bottom they got nailed down again. Now there's a couple things that braids are not allowed to do. Braids cannot go, braid strings cannot go up. So what I mean by that is if you have a string like this, it can't like go like this. That is not allowed because it was going up. See how right here it was heading up? That's not allowed. The braids have to always, the string has to always be going down. If we did this kind of thing, then we wouldn't be doing braid groups anymore, we'd be doing tangles, which is another kind of math.
Ooh, that's so tangles.
But we're doing braids right now. So that's a
I
rule.
know it was a draw.
Oh, well, you can draw what you want. You drew this beginning very nicely. Well, you have to let them, I mean, you could just draw that much. Here's a braid. 1, 2, 3, 4. Wham, 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 wham.
That's a boring braid.
That is a boring braid.
Is this a braid?
Which braid is this?
That's the null braid.
It is. It's identity braid, in fact, it turns out.
Wait, can we be going
Is this a
across
braid?
and then go down, down, down?
I think that's a braid, as long as which one's going over right here?
What do you mean?
In this crossing?
Where?
This one?
No.
It has to be clear at each place which one's on top.
Wait, so you can actually do this with string?
Yeah. You can actually do this with string.
Wow.
My goodness, you can make braids.
I decided to do mine in string.
So, but this is how we draw them.
I
Drawing it on paper.
prefer.
Okay, so we have an identity element, this is it. But let's talk about what the operation is. I think we talked about this a little bit last time, but the operation is, suppose I have these 2 braids. This one. And then I had another braid, and it looked like this. I'm gonna squeeze it on over here. So those are my 2 braids. The operation that we would use to combine them, by the way, do you want to call it braid multiplication, braid addition, braid
Subtract.
joining? What do you want to call it?
Braid unicorn horning.
Braid unicorn horning, why not? So the way braid unicorn horning works is you hang one under the other, so that and you take away the nails. So if I was going to call this one braid A and this one is braid B, then A unicorn horn B
Equals C.
would be equal to this. I would take A, I would just draw it first, then I would take B and I would hang it underneath this one. So I have to draw B underneath A, and then what we do is we take away the nails in the middle.
Is this a braid?
So those nails are gone, and it
That
just gets
braid wouldn't
joined.
stay very well because
Yeah, what would happen with
they
this
would
braid?
just go.
As a person?
Join. This one just becomes, this is equal to that braid, isn't it?
Is this a braid?
So these 2 braids actually are inverses of each other. They undo to the identity element. Yeah.
Is that a braid?
No, you have to be able to tell which one's going over and under. See how you, every crossing has to have one over and then one that's broken to go under. Or it could be the other way around. So you can't have this because it's not clear which one's on top. See what I'm saying? So you have to make it clear. Okay, so we have inverses. Now let's think about, does every braid have an inverse?
Not necessarily, no.
Okay, let's try it. Let's draw a braid and see if we can figure out what the
Like
inverse would
that
be.
one right there.
This one right here?
They can't have numbers 'cause
So let's see. If I drew that braid again, could we hang anything under it that would undo it?
fun.
let's try. I'm going to draw it up higher so we have room to hang something under it. So let's see, did it cross over, crossed, crossed again,
Well,
and then here, it
I
looks
see a
like
way that it could
I have a
go.
question.
this one crossed,
I see a way that you can
And
do
then
it, so. Yeah.
this one crossed. Yeah, what's your question?
No.
Do you still have that question?
No.
Are you sure?
Yes.
Now see, now I'm all curious what your question was.
Well, could you go from, so say, the one on the far right,
Uh-huh.
and make it go all the way to the one to the far left, or no? Like
Oh,
one
you mean just in
like-
one fell swoop?
Uh-huh.
It not all at once, because it would have to cross over or under the in-between strings sometime, right?
Uh-huh.
So we always just take it one at a time.
Okay.
And we think of it as one crossing at a time, really, usually. This one, technically, there are two crossings here, but I could think of either this one is first or that one's first. I could sort of decide. Those two don't matter very much.
I can draw a
Okay,
braid
so
that's
can anyone
inverse.
draw the inverse?
Yeah,
I'm
I
gonna
can do it.
let's use a different color.
I can do it.
Can you?
Yeah.
Okay, come on up. Try to draw the
Can I
inverse
draw it
and then,
directly under?
yeah, draw it directly under. And let's
We
see.
don't-
It's a braid.
Braid, we will not.
That's a braid, and he's gonna try to draw the inverse of that braid.
It's a braid.
I think it is. Yep. It's the do nothing braid though, because it's gonna untangle. You see how this string is just gonna lift off? You see it?
But it will keep going on forever.
Oh, well, you'd have to keep drawing then.
Is this a braid?
Nice one too. Yeah. And so then think about what would you have to do to invert that braid. Undo it. Does anyone have any thoughts about what you're looking for when you're trying to undo a braid?
Hey Amanda, I wonder if it'd be easier to do this on graph paper.
It
Just
might.
because it'd be easier to maybe show, I don't know, I'm just, as I'm sitting here trying to draw what
We
you
do have graph paper. Does anyone want some to try?
Do you see what I'm saying? So
I
that
think
you
so.
can clearly
Graph
delineate,
paper.
yeah, just one.
Yeah, everyone take a piece and pass that around. I think that's the
I
good
need a
size to
graph
use.
paper.
Okay.
Because in terms of like where they kind of, that one cross, you know what I'm talking about? I don't know, I just, as I'm drawing it, I'm like looking at it going.
Yeah, that's a good idea.
It is a good idea.
Is this right?
Here, take it quickly because everyone else needs one too. Reza and Aiden still need one. Is this okay? Let me see. Now, can I tell which one is crossing over and under though? Which? You see how yours are just crossing? I can't tell which one's on top because Agent, you see how this shows that this one's on top? This shows that this one's on top, but this I can't tell which one's on top. So it needs to be clear at each place.
Actually, you can with the top one because there's a little bit of white in between.
Yeah,
on
that's
the bottom.
true. But it's sort of hard, well, with pencil, it's really hard to tell.
Can you read it in this? This kind of net? Not that. Let me show you what kind of net.
You draw it metal.
Oh, this is kind of confusing. To draw.
This.
You know, I think the inverse of braid might just be the braid flipped upside down, because that's what it's starting to look like to me right now,
What do you think?
kind of.
All right, does anyone else have a thought about that? Yeah, Grace?
This. Thing.
This is too confusing to finish drawing, but
Well, right now, I'm saying that if you just like with that braid, I copied it down, and it looks like if you just hung strings from the bottom, since most of them are either under or over, that it would just untangle. Like one's like
So what would you do first? What would you untangle first on this braid?
I would take the string that's going on top of everything and move it
that
way.
would be that would be off to the side and then
Yeah, but if you just hung strings from the bottom, this one would just go. It kind of is.
if you just like hung on from the bottom it would be
Yeah, but they're nailed down at the bottom. So
Yeah.
this would go just boom and then boom. It would just be an angle and it would still go down.
But remember, the in-between nails get taken out.
Yeah, I know,
Yeah.
but that would still be connected at the bottom to
Yeah.
here if you
Yeah.
just hung a string.
Right.
So you need to have the strings and put them to where these start.
Right, so they better
And
get back
that-
where they started,
And
right?
flipping it upside down works to do that.
Mm.
So, yeah.
like that. How to calculate this?
Is that, well, we'll talk about that one later, okay? Because we're talking about this right now.
Later, how much later?
Later,
10 minutes?
we'll see. So, let's look. So that's a good observation. So which crossing would you want to undo first in this one?
I would do the one that, well, you know,
The one
can I show
that-
you something?
Yeah.
Leftmost.
See?
Which one would
This one?
could we undo
It's
first?
already neutralized. You don't even have to do anything to that.
Are you sure?
Yeah, it just needs to go
No.
down since it
Wait.
ends where at the same point where
Yeah.
it started. But flipping it upside down would
Okay.
make it proper inverse.
So what would you do first? What would you do to what would you hang underneath that would cause it to untangle a little bit?
Well,
That's it.
a
That's
string going
it.
from here to the leftmost
I got it.
and that one.
Then that can just go straight down, right?
Okay,
Then this
that sounds good.
Then that one needs to go to there. They might be overlapping.
Zero thing.
That's the problem. You
So notice, wait,
Flip it
step
upside down.
away for just a second so people can see. Step to the side. So which crossing did he undo first, you guys? Which crossing did he undo?
The
Oh.
one between,
This one,
yeah, that one.
right? So this one is undone now by hanging this under here. So now this part didn't happen. It's kind of hard to
you just have to
see it.
flip the braids. That makes sense since it's the inverse.
All
There,
right.
it's completely ruined. I ruined your braid.
So let's see. Do I
Right?
think that?
Oh, yeah.
Right.
There would be strings of different lengths going all.
That's okay.
along
We
with it.
pretend that they all get slurped back
Yeah,
up, right?
they're
Like they're
elastic,
elastic.
yeah.
Yeah. So they would get slurped back up. Do you think?
Mhm, that works.
Well, let's trace it. This
And upside down.
this string here went under, right?
Yeah,
And now it goes under. So it's untied, right?
Oh,
And that went over,
One of them's
over,
wrong.
that went over, so.
Yeah, the string,
the,
you drew
second to the left.
one
It
of
needs to
them
go that
wrong.
way.
Oh, is there one that's? Can you come up, Agent, and
I
fix
think
it?
it's the one that's
Come up and fix it.
Under,
Is there one that's-
over, it's going, that one is going under all the times, but you made it go
I think
over
it's-
once.
This
Where
one
was
says
it?
It's getting pulled that way
Here.
instead of.
Yeah.
So, do you wanna? There's the blue marker. Go ahead and fix it.
You need to
So just delete wherever the.
make that go over instead of under. And just flipping the braid works.
Flipping the braid would work, but this one also works. Right?
Well, flipping the braid makes something.
Oh, I know that one.
I think-
So is it right the way it was?
I think,
Okay.
So, yeah.
So let's see. So we are we all convinced that this string is going to come untangled?
Yeah.
That one's good.
yeah,
How about the first string? Is it good?
Yeah.
yeah.
Okay. So those two strings are fine. What about the second string?
Yeah, that looks,
After the first one's lifted
Yeah,
off
that
and
looks
the
right.
last one's lifted off, is that going to be okay?
yeah, everything's gonna be okay.
And then the
And he
third
just drew a
one.
shortened version of the flipped version of
The
that.
third one is definitely going to work.
Third one's definitely going to work too. So I
The only
think,
problem I see
yeah.
is that when you drew the braid, the this is the same braid as that, right?
Yeah,
These two are the same.
I think so.
This one goes over. They're supposed to be the same, but this one goes over, and that one goes.
Oh, did I
under.
mess it up?
Yep.
I did. So the only
So-
problem was my problem.
Yeah, but
Back
still,
over
that's
here.
the inverse of that.
Fine.
So as long as we didn't, yeah, okay, good job. You're right. But I think that one unties though, right?
That one unties, yeah.
Just so you know, there is a way to name a braid. So what we do is we name it from the top to the bottom based on which strings are crossing over each other. So what letter do you want to use?
A, B, C, and D. Well, actually.
Oh, only one letter.
Omega. A.
Omega, why not? Actually, in the literature, people use baby sigmas. Maybe we should do that,
Okay.
just to be like the people in the braid. The people who write papers about this use baby sigmas. Aren't they cute? They're like little O's with hats on them. And they make the sound S in Greek. It's like an S. Yeah, baby sigmas. The grown-up sigmas look like this. They also make the sound S in Greek.
That's like capital.
I like baby sigmas better.
Baby sigmas.
But
So-
grown-up sigma?
So we have a baby sigma, and what we do is we name, under each baby sigma, we list which string was crossing over which one. Do you want to consider this one to be first or this one to be first? Which one do you think is a little higher? Doesn't matter to me.
Right.
Okay, so let's call this one first. Which two strings, this is 1, 2, 3, and 4. Which two strings are involved with that crossing?
3 and 4.
3 and 4. And which one is on top?
3.
The 3. So we call that sigma 3 because the third string is the lower number. We'll see what happens in a second. I'll show you. This would be sigma 3. Sigma 3 inverse would be the opposite of that. What I should have drawn. So that's sigma 3 inverse. It's still called 3 because it's the third and fourth string, but we call it inverse because the fourth string is on top of the third string. If the third string is the one that's on top, if the lower number string is on top, we just call it plain. But if it goes the other way, then we have it inverse. So let's keep on going. So we have a sigma 3. That's this crossing. Then what's this one? What will this one's name be? Which two strings are involved?
Sigma.
Yeah, it's going to be sigma
Sigma 1.
1 because the numbers 1 and 2 are involved and 1 is lower. And is 1 going over 2?
Yeah.
So it's just a plain old sigma 1, not an inverse. Okay, now down here, this one's a little bit confusing. Even though this is really the first string and this is really the fourth string, if I look at it where it is, like I ignore where it came from, I just look at it right here. Right now, this isn't the first string anymore. Which string is this? If you didn't look higher up.
That's the second.
It is the second, and this one is the
Third.
third. So it's the second and third string. So what will we call that one?
Sigma.
So it's the second and third. So pick the lower number. 2. So sigma 2. And is it an inverse? That is the third one crossing over the second, or is the second one crossing
No,
over?
the second.
So it's a normal one. Okay, what about this one, you guys?
Wait, which one did you just do?
So we just did this one.
And that was 3 and 2?
That was this one. The sigma 1 was this one, and sigma 3 is that one. So now we're on to this one.
But
That was
wasn't
Would that be
Sigma
sigma 1?
2?
Wait,
wasn't,
Autumn has a question. What was your question?
But it was 1 and 4 crossing.
Yes, exactly. But we don't look any higher than right right there. So we don't even look where it came from, we just look right here.
Okay.
That is
Yeah.
weird,
So
isn't
it's
it?
kind of like using coordinates on a coordinate plane.
It is.
And that's the point.
Exactly. As soon as it's crossed over, it's considered the second string now.
Then that next one that you're looking at?
Yeah,
That's-
Sigma
that was
one?
Sigma 1, yeah.
It is. Sigma 1. And is it inverse or not? Not. Not yet. It's still the first one going over, right? Okay. What about this one?
That's sigma 2. Yeah.
2.
No, that's Sigma 3.
No, it's not. We did lower one.
it's 2.
It's sigma 2.
Which one?
This one.
That one? That looks like Sigma.
Which two strings are involved? String number what and what?
2 and
3.
2
Two
and
and one.
3.
No.
Remember, we don't look where
Oh,
it
yeah.
came from. I know. So it's 2 and 3. But which one's on top? 3. So we call it sigma 2
and it's inverse.
inverse. Because the 3 was on top. Yeah, Luca.
Oh, I get the inverse.
You get it? It's when the bigger number is on top. How about this one?
Oh, that's sigma 3.
Inverse.
Sigma 3 inverse. Okay? Okay, so down here, we were undoing things. It looks like this one's the next highest up, right?
Yeah.
So let's look at this. What is that?
Sigma 2 inverse.
Sigma 2 inverse.
Then it's 1.
Actually, not quite.
It's 1.
1 inverse. Why is it 1 and not
Yes,
2?
yes, yes, yes.
And then
The first, the lower numbers.
Yeah, first and second string. This is always the lower number. So this was the first and second string.
and
The
then
lower
So
one is 1,
this
but the 2 is on top.
This is next.
Which one is next?
that one.
It's hard. It's this one, right?
Yeah.
Okay.
So that would be sigma 3.
Sigma
And
3.
it's kind of hard to. Oh, it's not inverse.
No, not yet.
Yeah, the 3 is going over, right?
Yeah.
Okay, what about this one?
That's sigma 2.
Sigma 2 inverse.
2 inverse. And finally, last one.
That is
Oh, that's
sigma
sigma 3 inverse.
Not inverse. It's
No.
Is it inverse or not?
No.
I think
It's inverse. It's inverse.
3 is going over.
Yeah, this is 1, 2, 3, and 4, right?
See, 3 is going under, so it's inverse.
Inverse.
Are there as many inverse sigmas as regular sigmas? Yes, there are.
Yes, there are.
Is that always like that?
Well,
Yeah, because
and
every
grade,
in a group, every element has to have an inverse. So
and that's an undone braid, so it has to have the equal
Now,
amount of inverse.
actually, I want to see if we can prove that. The braid word, and you guys want to do this the way they do this in Braidland? For real? They do it backwards.
No, that seems confusing.
So they would write that like this. Or would you rather write it from left to right?
Left to right.
Okay.
I don't care as long as we all agree.
Wait, how
Left
right,
or
left to
right?
right?
How many people want right to left?
You mean left to right?
Right to left. How many people want right
This is
to left?
half of a vote.
Okay, how many people want left to right? Oh,
This is a
gracious.
quarter of a vote.
Oh, so some people don't care. I think more people voted for right to left, so we're gonna do it the way they do
Yay!
for real in the
Even though I
literature.
happen to-
So, there it is. That's fine. It doesn't matter which way we do it, but as soon as you start reading it, whenever you read a paper, you always have to understand what their terminology is. So we have this big long braid word, and I think I copied that right. 3, 1, 2, 1, 2 inverse, 3 inverse, 1 inverse, 3, 2 inverse, 3 inverse. So now, we're claiming that this is actually equal to the braid identity element, which they usually just call, some people call that E, some people call it 1. What do you want? E or 1?
1.
1.
Or you can do none.
Or we could do 0, that's another option. But because we're using multiplicative notation, it makes sense to use the multiplicative inverse.
E power like
Done?
that.
No, just
Oh
E.
no, that's
Yeah, I know.
favorite.
You like the E?
Yeah.
Yeah, that's a good
He was
number.
my favorite friend.
He is a good friend. Okay, but we're just gonna do one. So, now,
E.
let's see if we can actually show this. So, let's see. What are the rules? Suppose I have this word. Sigma 3, and then I have sigma 3 inverse. Can anyone come up and draw this word?
It's already up there.
Yeah, but just that part. Oops, I'm sorry. Can you draw? And remember, this one is on top,
Yeah,
and then this one's underneath.
where should I draw?
Wherever you like. That's gonna be a little too close together, though. Be bigger.
Okay.
Be big because people will have trouble seeing
Big
it
and
from,
bold.
from back there.
Okay,
So first do the sigma 3.
three. So these are just straight. 2, 3. Alright, this one.
Here you go. Right, because sigma 3 means 3 and 4 are gonna cross, right? Remember to make sure you tell us which one's on top.
Yeah.
Oh, that one.
It's just a 4.
Are you sure?
There we go.
Yes, just possible. B.
It's a 4.
That's a fire. I saw it with my eyes really close.
Okay, so does everyone agree that this is sigma 3?
Yeah.
And that this is sigma 3 inverse? Okay, so,
get another piece of.
mhm, definitely.
No, that's fine.
The graph paper?
No, this.
There we
These
go.
kind of sheets.
Okay, does anyone have, what do you think the rule is? Can anyone tell me another word? Does this equal the identity? Does this equal 1?
Yeah.
Yeah.
Can anyone tell me another word that would equal
Sigma
1?
2 and sigma 2 inverse. Sigma 2
That equals 1.
Sigma 2,
Yeah.
sigma 3, sigma 3 inverse, sigma 2 inverse.
Okay, say that again.
Sigma
Sigma.
2, sigma 3, sigma 3 inverse, sigma 2 inverse. That's all.
So this would go poof, and then that would go poof. Is that good? Equals 1? It's like cancellation.
Sigma 2, sigma 2 inverse, sigma 3, sigma
Why do we
4,
choose
sigma 4 inverse, sigma
Oh, do we have any
3
sigma
inverse.
4s?
Oh, no.
Okay, so sigma 2 inverse, then what?
Sigma 1, sigma 4.
We don't
There's
have
no sigma
4s.
4.
Oh, yeah, sigma 3,
3, okay.
sigma 3 inverse, sigma 1 inverse.
Sigma 2 inverse, sigma 2.
Sigma 2 inverse sigma 2. All of that equals
1.
One.
The identity property.
because these cancel out right away, this cancels, and then those will cancel, and then those would cancel, right? Cancel, cancel, cancel. So this is one of our,
But you forgot to put the oh, never mind.
so this is one extra special property of braid groups that that they cancel, that inverses cancel each other out. And we knew that that's the idea that when you combine inverse elements, you get the identity, right? What's another
You mean
rule?
50 unicorn horn in inverse element?
Right, if you unicorn inverse elements together, then you can get 1. Let me try this. There's another property based on this braid. And I wonder if you guys can tell me what it is. There's another cool thing that braids can do. Can they unicorn?
Associative property?
Well, yeah, let's look at that. What would the associative property look like for braids? Give me an example. Give me three braid words. Autumn, any 3. You can say sigma 1, sigma 2, sigma 3, sigma 1 inverse, sigma 2, inverse, sigma 3 inverse. Any order. Give me 3 of those.
Okay, sigma 1,
Okay.
sigma 3,
Okay.
sigma 1 inverse, and sigma 2 inverse.
Okay, so we're just gonna do that?
Oh, yeah, that's 4, sorry.
Well, let's just stop with this one for right now. So let's look at this.
Well, that would just be sigma 3 since the 1 and 1 cancel each other out.
Well, let's draw it. Can someone draw it? Grace?
I
Oh,
should.
Autumn, let's let Autumn do it since she came up with the
So
grade.
it would be so it would just be
You're still having 4 strings.
oh right, so it would just be this one would just hang.
So remember, do it from right to left. So the first one you want to do, here's the rack. So the first one you want to do is sigma 1.
So sigma 1.
And everyone look and make sure they agree.
Wait, so could I just do like a line?
Yeah, the other ones will be just a line, but sigma 1, where will sigma 1 be? Which 2 will be crossing for sigma 1?
1 and 2, and 1 will be on top.
1 and 2. So
Wait,
you're gonna,
are we gonna do this? Wait. Oh yeah, it's right
so which one will, so you want to,
Not
That's
1 and
that's
2.
3 and
3.
Oh, you're right. So we're doing left this way?
oh no, sorry, we're reading the word up on top. Point to those letters, sigma 1, sigma 3. Yeah, we're reading that from right to left. The words.
Right to left. Okay.
Sigma 1. Yeah, this is really confusing.
But we're doing
But we're doing the strings from left to right. Yeah.
Okay.
Just to be really confusing.
Okay.
Okay.
So
So string 1 is on the left.
Right, left to right?
right.
Left to right, that's 4.
This way. Okay.
No.
3.
no.
That's 3.
Number
This
them.
one.
How about you
Number
number
that. That's 2. Number it.
What?
Number it. That's 2.
This is 2.
That's 3.
This is 3.
This is 4.
There you go. And where's
That's
1?
Oh yeah.
Okay.
That
So
helps.
sigma 1, which 2 are going to cross?
Okay. So what?
So which 2 are going to cross for sigma 1?
They just had to make this confusing. Sigma 1
I know,
is
because we're
gonna be
doing
on
some
top.
of it right to left, some of it left to right. It's all.
So sigma 1 was
So, crossing sigma 2 on top.
and 3, right? 2 and 3.
So we're doing
No.
sigma 1.
No. Right
Sigma
to
1 and
read the
2.
words right to left, and you write them.
So which 2 should cross? Which 2 should cross? 1 and 2.
Okay. So
And which one should be on top for sigma 1?
Sigma 1.
1.
One.
So string 1 should be on top. Perfect. And the other ones should just go down.
But what about
I know, this is totally weird. So that's sigma 1. You've drawn the first, we're reading that word right to left. So now you're ready to do sigma 3.
sigma 3 crosses
It's
over
on top, it's on
3
top, okay?
on top of 4.
3 is on top of 4.
No, that would be sigma. Wait.
Yeah, that's right.
Yeah, that's right.
Bananas.
Those
Bananas.
and then finally
Bananas.
do
And then-
sigma 1, but 1 is on the bottom. Since it's inverse.
No.
There we go.
Did she do that right?
Yeah.
Absolutely. All right.
So that means that
It would all just cancel out besides the
Well,
part of
so
it.
what will happen with this?
Missing its arms and legs.
It's a turtle
Will it all
missing its
just
arms and
straighten out?
legs.
wait, yeah, because this one.
And his arms and legs
Will this
are on the
one, will
right.
this one straighten?
It's a turtle missing its arms and legs.
And his arms and legs are on the
Here,
right.
step back from it and look at it.
His arms and legs are on the right.
So Adam, which ones will untie?
Which one? First one was the string number 1 would untie.
Uh-huh.
And then 2 would untie.
Yeah. How about 3 and 4? Will they untie?
No, they're not long enough.
They don't have
It's
any.
stuck over here. But that's
Yeah,
cool. So that's a good example. Now, here's my question. Does the associative property, this is what Grace was asking, does the associative property apply? So what would it even mean?
You could move strings
So-
around.
So the question is, how would I draw, where should I put parentheses in on this?
3 and 1.
So first we'll put it here,
Yeah.
and we're trying to see, is this equal to what?
Is that equal to parentheses -1 and 3? No, negative inverse.
That's what the associative property would be saying, right?
But what would parentheses do to the phrase?
So let's look at this.
You would do the parentheses first.
So you would do the parentheses first, that would look like this, right? And you would put nails in, right here.
And then you would.
And then you would hang this
Yeah.
under it, right? does that property, does that seem to be equal to what we would get? What does this mean?
Well, maybe we should draw it.
Okay, let's do it.
So first we have 1.
I'm gonna draw just the strings without the nails.
First we have 1 inverse, and then we have 3, then,
It's the same.
yeah, the same, but instead of,
We start with this part first, right?
oh yeah, 1 second, but that's not inverse. You need to do that inverse. But it comes out to the same thing because,
Well, no, remember, we do this one first,
oh yeah, yeah.
sigma 3,
But
then
you
sigma 1 inverse, and then you hang it under sigma 1. Because
Why,
this means
oh.
hang this one on top.
Yeah.
So here's the sigma 1,
Yeah, it's the same thing.
here's the sigma 3, sigma 1
It
inverse.
works.
So it is the same. So
I
the
can tie
associated
it
property.
not with the braids.
Someone tell me this though. Would sigma 1, sigma 2 be equal to sigma 2, sigma 1?
No, because they'd be at different heights.
Let's see, who would like, Grace, would you like to draw this one?
Yeah.
So what's this property called? If this were true, if you can, what would this property be called? Not the distributive. Distributive is if you have addition and multiplication, right? You have to have two operations for a distributive property.
The,
What's
I
another?
can put things in any order I want.
Exactly, the property of I can put things in any order I want to. What's that also called sometimes?
The
Good guess, but not quite.
communicative.
Commutative. Commutative.
Commuting back and forth.
They're commuting back and forth.
Bananas.
Bananas.
So what do you guys think? Is that,
That's the.
which one is that, by the way?
That's with.
Is that the one on the left or the one on the right?
That's one on the right.
It's the one on the right, but that's okay. So that's cool. So that's one. Now do the one on the left.
They might turn out to be the same thing.
They might.
Are we gonna still do banana split?
I think we're gonna have to start in on banana splits. We'll just get going a little bit with them today. We'll brainstorm a little bit on banana splits.
Are we gonna use bananas and splits?
I don't know.
Maybe you can split bananas.
Maybe
Maybe
we'll
we'll
do
do the
this.
splits while eating bananas.
No, it's not banana splits.
Banana
That's
with bananas.
Split banana splits.
I don't understand. I don't know the sigma 1 and sigma 3 and then the sigma 1 inverse. I don't understand how you know the sigma 1 crosses back over the 2. Why doesn't it just, why doesn't it cross the thing on the other side of it? Like before,
Which on our second?
on the earlier thing.
I think that's right.
We'll ask that up here in a second. So, okay. So what do you guys think?
Well, that ends up there.
Are these the same?
No, no, well, that one ends up there. No, the commutative property is not,
It's not
does
true
not apply,
in general, at least.
does not apply to all grades.
However, these would commute. Do you see this one and this one?
Yeah.
You could slide them up and down. It wouldn't make a difference which one's higher or lower, right?
Yeah. You can do the same thing with.
So some braids commute, but some braids don't commute. That's the thing that's weird. Cool. What was your question? Say that again, because that was a good question.
I didn't understand,
Okay.
back when we were doing the sigma 1, sigma 3, sigma 1 inverse.
Up here?
No, that one, yeah,
This one.
that one, on the left,
Mhm.
part of the equal sign, yeah. I didn't understand, after you did sigma 1, and then you did sigma 3, and then you got to sigma 1 inverse, so you have to like cross over your sigma 1 over a bigger number.
Mm-hmm.
Why you cross over 2, why don't you go the other way and cross it over the thing on the other side of it, which is 4.
So the number down here always tells us which two strings are crossing. In this case, it's string 1 and 2.
You can only cross with your next higher, you can't
Yes.
cross like string 1 with string 4.
No, it's always named for the lower of the two numbers. So this number always matches that. And then this tells you which, if the bigger one was on top, you make it inverse. If it's a smaller number on top, you would make it regular. That's the craziness of the notation, but yeah, that is it. So this is, now there's some other properties of braid groups that you could use to prove that this really does untangle to 1, but we're gonna leave that and come another time. Let's start brainstorming about banana splits. Yay! So the thing about a mathematical system is when you are doing banana splits or whatever any kind of math, you have to have objects and you have to have operations.
Okay.
Yeah.
So we need objects for our banana splits. Yes.
I think the most common one would probably be banana.
Oh.
Ice cream.
So a banana split, though, all of them would be banana splits, but they would have different ingredients in them.
Yes, ice cream.
Sort of like a braid has different
Oh, so we
crossings
should do
in it, right?
banana with ice cream on top.
So banana splits
Bananas.
Chocolate sauce.
are just anything with a bunch of operations. Now I have a concern. So what are the ingredients or what are things?
Whipped cream.
Oh, there's bananas, strawberries.
We have
and
bananas,
ice cream.
I'm allergic.
bananas, strawberries. Which one are you allergic to, Grace?
Walnuts.
Don't
Okay.
put those in there.
So no walnuts.
Ice cream, of course.
Ice cream,
Chocolate sauce.
Pineapple.
Whipped cream.
chocolate sauce,
Slow down.
pineapple.
I'm getting sick of
I'm having trouble writing this. Whipped cream.
I need
Yeah.
one.
Caramel sauce,
Cream.
chocolate chunks, sprinkles.
Caramel sauce. Wait a minute, I'm still.
Whoa.
Caramel sauce.
Chocolate chunks.
draw that.
Banana.
Chocolate
strawberry
chunks?
is
Now can you draw it?
Chocolate chunks.
Yes.
Okay, I think actually I'm gonna stop. Well, why do we have to stop? Okay, chocolate chunks and sprinkles. All right. Now we do have a problem though.
And me.
There's too many.
Well, it might be. We might want to rein ourselves in a bit. But let's think about this. The problem is if it's going to be interesting mathematics and not just tasty. Tasty is good. But if it's going to be interesting mathematics, you have to have rules about how they combine to make other things. So you have to have
Ice cream
an
and chocolate sauce
operation
makes
where
chocolate ice cream
bananas.
sauce.
Ooh, let's do lightsaber.
And what would the operation look like?
Lightsaber.
Lightsaber.
Lightsaber. We
No,
lightsaber.
ice cream maker.
You just here. Do you want me to draw it?
Yeah.
How about cup? Cup with reason.
Careful. Don't take out the room. Draw the operation symbol between it. Okay, so bananas lightsabered with
Problem 3.
what? What other thing would you put with bananas?
Walnuts.
Walnuts are in the left.
Ice
Whipped
cream.
Strawberries,
Ice cream.
ice cream. I'm just going to do that. It has to equal something else on the list.
Chocolate sauce.
It equals chocolate sauce. So that's the thing. If you're going to have interesting mathematics, you have to have some sort of rule about how these things go together to make other banana splits.
Hey. Chocolate
So-
sauce neutralizes caramel sauce.
So we have a
That
couple
should be our
options.
rule.
To make this interesting mathematically, we might want to start with fewer ingredients just to get a handle on it. Because otherwise we have to say,
bananas,
what
strawberries,
does
and ice cream.
bananas and ice cream do? What does bananas and chocolate sauce do? What does bananas and everything do? And that might be a lot. What?
Maybe
Yep.
we should just use 3: the banana, strawberries, and ice cream.
Just start with those 3 to start with. Okay.
Or should we do 4 and have the chocolate sauce?
If you guys want chocolate
Oh
sauce
no,
too.
let's
Yeah,
do whipped cream.
yeah.
Whipped cream.
Okay. How
sauce,
many people want chocolate sauce?
This
How many
is
people want whipped cream?
1/16th of vote. This
Please
is
vote.
1/32nd of a vote.
I'm afraid that the. Okay, I lost. Try it one more time. Chocolate sauce.
16th of a vote.
Yeah, you're just confusing me. And whipped cream.
256th of a vote.
I'm thinking chocolate sauce is winning there. So we've got 4 ingredients. So then we have to come up with a way. We're gonna have to figure out if we have bananas.
That's gonna be 4 to the power of 4 things.
Has anyone ever seen a multiplication table?
This is gonna be 16.
Has anyone ever seen a multiplication table?
Yes.
We call that, in math, we call that actually a Cayley table. Cayley is spelled like this. Cayley table. And it just means you're just spelling out what are all the different combinations that you can get. I'm going to abbreviate here. I, C, and, so we're running out of room, chocolate sauce. We're going to have to figure out what happens if you combine it with bananas,
Bananas and bananas. make more
strawberries, ice cream,
Whoa.
and chocolate sauce. We're going to have to complete the Kaylee table
bananas.
for
plus
what happens
bananas
when
and
you
bananas.
lightsaber each of these ingredients with
That's
the other
seven.
ingredients. And we'll have to figure out what that is.
Banana and a lightsaber with bananas
Right.
equals 2 banana.
Two bananas.
Is it 2 bananas? Now,
Bananas.
here's the thing though, we have to have it,
banana
if it's gonna be a
equals
group,
inverse banana.
yeah, if it's gonna be a group, remember, there has to be a nothing split, a nothing banana split. And there have to be some things that get lightsabered together to be nothing.
Ooh, strawberries
That should
and
be like-
chocolate sauce.
That should be
get
bananas.
nothing.
That should be like bananas and strawberries get like.
And what's the
together
symbol
and
for nothing? What's the symbol if two things get lightsabered together and
Walnuts.
they annihilate?
Ooh, ooh.
Walnut.
It
Yeah?
becomes
Explosion.
two lightsabers cross.
A knife.
A knife.
I think it should be two lightsabers
Walnuts.
Like
Two
an
lightsabers
X?
crossed.
Just be a skull.
Yeah, like two.
That's sort of like a
lightsabers
knife.
It
crossed.
should just be a skull.
A
Or it
skull.
could be an empty ice cream dish.
So something like this. Is that
Yes.
Yeah.
Autumn? Do you? I can draw that.
What is that?
I don't know. I was trying to be a skull, but maybe you can draw a better one.
Sure.
That was supposed to be
I'm not very
skull.
good at skull.
I can draw skull.
Okay, if you can draw, if you
There's
can make me
a
a simple symbol, I'll
Yeah,
use it.
okay.
I can draw a
Okay.
skull.
Okay, here.
Wait, no.
That looks like a loaf of bread.
Yeah.
That's be simple enough. I can handle drawing it.
It could be a loaf of bread. We could do that.
Oh, that's not too bad. I can handle that. Oh, that's
What is
cute.
that?
I can't see. I can't see.
Okay, that's adorable. Okay, so that is what we draw. Let me see if I can draw that.
Bananas
So which
combine.
two things will combine to give us
Bananas and bananas.
Bananas and
identity?
bananas.
Okay,
Bananas
bananas and
and
bananas. What do we call this, by the way?
Death.
Inverse.
Death.
Death.
Death. Death is our identity.
Game
moment.
over.
Okay, game
Game
over.
over.
No,
Yeah, I
death.
like that.
So let me see if I
Game
can
over.
draw. I'm not as good of an artist as she is, but I think I
Charlie,
can
game
draw
over. It's a game over.
something like that.
Anything
It looks like an
lightsaber,
alien.
anything lightsaber with itself should be death.
You think so?
Yeah.
So that's how it's
No,
gonna
it's
work.
game over.
It's game over.
No, it's death.
So that's where we need to pick up next week. We have to decide for this whole Kaylee table what everything is going to lightsaber to make, and then we will have our own
Strawberries and
mathematical
bananas make
system.
ice